All right, number 7, similar to number 6, we're going to do 3 parts. We're going to use the Cartesian rules to determine the number of possible positive and negative real zeros, and then we'll find upper and lower bound, and then we'll actually find the zeros. Okay, so we look at the number of sign changes. This first sign is positive. The second one is positive, so no change. It's still positive, no change. It changes to negative, so that's one sign change. So it stayed positive until we got to the fourth term. So there's one sign change, and it stays negative. So the number of possible real zeros is just 1, because we only have one sign change from the start to the end. Okay, so you just count how many times the sign changes. Now, when you do the negative, we actually have to plug in negative x's. Okay, so I'm going to take the polynomial, and I'm going to say negative x to the 4th plus 7 negative x to the 3rd. So you're plugging in negative x, therefore you have an x, plus 3 negative x squared, and then minus 63 times negative x, minus 108. So when you evaluate a negative x to an even degree, it's going to come back out even. So this will stay x to the 4th. It's going to be positive. A negative x to an odd degree will become negative. So negative times positive, this will become negative. So 7x cubed. This will be positive, and this is positive, so still positive, positive 3x squared. This is odd, so negative times a negative, this becomes positive, 63x, and then that will just stay negative 108. So once we insert the negative x, we now count the number of sign changes here. So we have positive, negative, that's 1, changes back to positive, that's 2, stays positive, still 2, changes back to negative, that's 3. So there was 3 times that the sign changed. So either there's 3 negative zeros or a smaller number by even integer. So I subtract an even number. So minus 2 from 3 will leave us with 1. Okay, I can't go into the negative. So either I will have 3 or 1 negative real numbers. Okay, so we're going to say 3 or 1. So 3 comma 1. All right, now that we know sign changes, we want to compute bounds. So the rule was we're going to do synthetic division with positive numbers, and we want the last row to be all positive to find the positive bound. This time I'm going to start out with number 3. I'm going to start out with a bigger number, and then I'll go backwards if I need to. Okay. We're going to start out with leading coefficient of 1, then 7, then 3, negative 63, negative 108. Okay, and we want the whole last row to be positive to get an upper bound. 3 times 1 is 3, add 7, we get 10, 3 times 10 is 30, add 3, we get 33, and then 3 times 33 is 99, add or subtract 63, because it's negative, we end up with 36, and then 3 times 36 is 108. And combine those, we get 0. So this one just happens to work out just nicely. Notice also we had a remainder of 0, which tells us that 3 is one of those zeros that we will need. So 0 can be considered positive or negative. So since it's positive and all these are positive, then 3 will be our upper bound. I don't think if we use 2, it will be too small. It wouldn't work. So 3 is our upper bound. Just kind of got lucky there on the guess. Sometimes you got to try more than one. Now let's try for lower bound. So lower bounds, the signs need to oscillate between negative and positive. So let's just start with 3 as well. Let's kind of start with what we started, but we're going to do negative 3. Has to be a negative number on the lower bound. So 1, 7, 3, negative 63, negative 108. We need these signs to alternate between positive and negative. Bring down the 1, negative 3 times 1, negative 3. Add these, we get 4. Right away, I stop. This is positive and this is positive. This doesn't work because the signs need to change. Okay, so looking at these negative numbers, if I were to choose 4, negative 4, it would still be positive. I need something that's going to be 7 or bigger. Okay, so I'm going to jump all the way down to 7, just kind of looking at this and trying to make some mathematical sense of it. I'm going to jump down to 7, because that's the first one I see is going to give me a different sign here, which is going to give me 0. Negative 7. Okay, so 1, 7, 3, negative 63, negative 108. Bring down 1, multiply, that gives me a negative 7. Combine these, we get 0. So 0 can be positive or negative. Negative 7 times 0 is 0. Add these, we get 3. So I got positive, negative, positive. Negative 7 times 3 gives me a negative 21. Add these, we get negative 84. And then negative 7 times negative 84 is going to be a really big positive number. Let's do it, 28. 756 plus 2 is 58. So 588. So this is going to come out positive. You don't have to actually do the math. So look at the sign. Positive, negative, positive, negative, positive. So negative 7 is going to be our lower bound. Okay. So up here, we found out that 3 was the upper bound, and negative 7 is my lower bound. Okay, so when I'm trying real numbers using synthetic division, I only have to go as far down as negative 7 and as high up as positive 3. So upper bound is 3, lower bound negative 7. All right, now we actually want to find those zeros. So we're going to use the rational root theorem and list out the zeros, the possible zeros. So factors of 108, which 108 is a big number. 108 divided by 1. My leading coefficient is a 1. Okay. So I'm going to use the calculator to speed this up, and I'm only going to use the numbers that are no smaller than negative 7, no bigger than 3. That's my bound. Turn it on. Clear out y equal. Clear out what I have. We're going to do 108 and divide by x just to list all the factors. Second graph, and I'm going to go back up to the top. So the factors are 1 that I would need to use, and remember, positive or negative. 1, 2, move this mouse, 3, 4, 6, 1, 2, 3, 4, 6, and then I think we're going to stop there unless 7 works. I don't think, no, 7 doesn't work. Okay, so these are the numbers we're considering. Okay, we found that 3 was our bound, so 3, 2, 1, and then negative 1, negative 2, negative 3, negative 4, negative 6, 8. These would be the numbers that we would have to try. We wouldn't have to go any further than this. We have already found out that 3 works. So we're going to use 3 and make sure it works, and then we're going to find the other roots. Okay, so I'll try to show you some other methods instead of having to continue to do synthetic division and get them checked. So on the first step, we found out that there was 1 positive real 0, possibly, and that there was 3 or 1 negative. 1 or 3 negative. So from the work we did, we found 3 was the bound. We also found out that 3 ended in 0. So we're going to just use 3 again just to verify. We had coefficient of 1, 7, 3, negative 63, and negative 108. Okay. Do this with 3. Bring down the 1. 3 times 1 is 3. Add these, we get 10. 3 times 10 was 30. Add these, we get 33. 3 times 33 is 99. Combine these, we get 36, and 3 times 36 was positive 108. Combine those, we got 0. Okay, so 3 works. My resulting polynomial, since we started with a 4th degree, okay, dividing off one number would bring us down to a 3rd degree. Okay, so this is x cubed, 1x cubed, plus 10x squared, and then plus 33x, and they're all positive, so that's why we know plus, and then plus 36. Okay, when I get a trinomial, we can try another factoring method. Okay, we can try a factor by grouping. So I'm going to see if factor by grouping will work. Okay, so factor by grouping, we will group 2 terms together, and group these 2 terms together, and factor out the greatest common factor. So between these 2, they both have x squared in common. So if I factor out x squared, that would leave me with an x plus 10. In order for factor by grouping to work, whatever I divide out of here, whatever is remaining needs to be the same. And it doesn't look like that's going to work. Both of these are divisible by 3. So if I pull out a 3, this will leave me with 11x. Divide by 3, that will leave me with a 12. Okay, so you see how these 2 don't come out the same. Factor by grouping will not work. Sometimes you can rearrange and mix them up, but it doesn't look like it's going to work, so I'm just going to go ahead and continue with synthetic division. So I'm going to continue where we left off, 1, 10, 33, and 36. And let's try some of these negative numbers. So earlier we tried 2 and 3, and they didn't end in 0. So let's jump over here and try 6. Okay, let's try to see if 6 works. And then we'll go backwards from there. So we're going to try negative 6. And we're going to do 1, 10, 33, and 36. Bring down the 1. Negative 6 times 1 gives me a negative 6. Combined, we get a positive 4. Negative 6 times 4 gives us negative 24. Combine these, and we get 7. Nope. 6. 9. And then negative 6 times 9 gives us a negative 54. And this is not going to end up being 0. So negative 6 is not working. So let's go back and try negative 4. 1, 10, 33, 36. Bring down the 1. Negative 4 times 1 is negative 4. Combined, we get positive 6. Negative 4 and 6 gives us a negative 24. And we get a positive 9. Negative 9 times, negative 4 times 9 gives us a negative 36. And we get 0. Okay, so 4 works. Okay, so our remaining polynomial from here, it was cubed, now it is squared. So we have x squared plus 6x plus 9. Okay, so from here, we can see if this guy will factor. Okay, so we're going to try to factor this. Let's set it equal to 0. So factors of 9 are 1 and 9. And then we have 3 and 3. We have to add to get 6. So 3 plus 3 will give us 6. So it will factor. So we'll have an x and an x, these 2 3's. And in order to combine those to get a positive 6, they both have to be added together, and they both have to be positive. So here are my other 2 factors, x plus 3, which is x plus 3 squared. When you set each of these equal to 0, x plus 3 equals 0, you will get x equals negative 3. So it's a double root. You get it twice because it's the same thing. Okay, so our factors are negative 3. We found out that negative 4 works. So since negative 3 works twice, remember we saw at the beginning that there would be either 3 or 1 negative numbers. So negative 3, it works twice, and negative 4, so that's 3 of them. And then we found out that positive 3 works. So positive 3 negative 4, and negative 3, but we only have to list it once. You don't have to list it twice. So negative 4 and positive 3. So 3, negative 3, and negative 4.